Okay guys, let's talk about electron notation or electron dot notation. So I've started here, I have a column for my element. I need to know how many valence electrons it has, and I need to know what the notation would look like. And this you don't have to write down. In fact, you could do your answer right here on the element, but I'm doing this just for clarity. So if I look at our periodic table, I see that sodium on my periodic table here is in the first column. So that means this has one valence electron. These have two valence electrons. We skip over the D's. And this column has 3, 4, 5, 6. Let me slide this over a little bit. 7 and 8. And so we can just count across, skipping over the D, to determine how many valence electrons are in there. Or you can add up the S and P electrons from the electron configuration. So sodium, one valence electron. That means I need to put one dot on sodium. So I would write the element that includes all the core electrons. So the first 10 electrons are denoted simply by writing Na. And then when I want to add my dot, I can either add it to the right, to the left, to the top, or to the bottom. I'm just going to start here on the right. It doesn't matter. So let's do magnesium. And magnesium is in the second column, so it has two valence electrons. And in accordance with Hund's rule, we have to put our two dots on different sides. We could put them right and bottom, right and top, right and left. We just can't have two on the right or on any side. Boron has, and that's on the row above, so maybe we should use aluminum. We'll keep it all on the same row. Aluminum has three valence electrons, and again by writing Al, I have included the first 10 electrons. I only deal with the core electrons now, and I have three dots, so this time I'm going to put them top, right, and left. We get to silicon, has four valence electrons, and Si would denote again the first 10 electrons. We have four dots we need, 1, 2, 3, 4, and now you have to have one on each side. And now with phosphorus, it has five valence electrons. We need five dots, so 1, 2, 3, 4, 5. Would I know whether you put two then and 1, 2, 3? No, you can put them on there as long as you only have two electrons paired and one lone electron on each of the other sides. So to continue on, sulfur has 6 valence electrons. Just to give more room, I'm going to do it over here more in the middle. And just making sure that you can see those, I'm making them a little bigger. And when you do work for me, you should make sure that I can see your dots. They're nice and clear. After sulfur is chlorine, 7 dots, and I'm going to again stagger it over here so I have plenty of room. And you'll notice this time I'm just putting in the dots together, and I have one unpaired electron, and so that shows us why it only makes one bond. And then last in that row would be argon, and argon has 8 electrons in its valence shell, and argon would have all four sides with 2 dots. So I hope that makes everything clear, and we will be doing these in class, and we use electron dot notation to then do our Lewis structures. So again, talk to you later.